Hi everyone, this is Jeff Strain. I am a subject matter expert in the simulation area here at Autodesk. I'm here with a few other people from the Autodesk simulation group here on the panel, and we're going to begin our webinar series regarding the simulation mechanical transition with just a general overview of that transition. We'll be discussing essentially what's the going forward plan as far as simulation's role within Autodesk. We'll also talk about the various options that you have going forward. We'll talk about the Nass Training CAD, Fusion, simulation, and we'll dig into that a little bit. And then from there, we're going to follow up. We'll have a couple more webinars that are more deep dives, a little bit more technical than what we're seeing here. So we'll be digging into Nass Training CAD deep dive, showing you around there, showing the capabilities, some of the features, the strengths there, and doing the same thing with Fusion 360 simulation, showing the positioning of that, digging into the capabilities, the interface, and so forth. So I'll go ahead and get started. I'm going to ask a few survey questions starting off, and then at the end, we'll also throw a couple more survey questions at you. So if you wouldn't mind responding to it, that'd be great. It'd help us with our strategies for the next few webinars and help us to help you out as best we can. Right, so I'm going to fire off the first survey question. Okay. Okay, so let's look at about 50-50, actually a little bit better than majority, or actually just about 50-50 as far as discussing your options, your simulation options going forward. Okay, and just wondering about the CAD tools that you're currently using. I'll go ahead and fire that off. Whether you're using Inventor, SolidWorks, or some other tool. And give that a minute here. And as we're going this, we'll talk about the end-of-life plan for simulation mechanical. You're going to see that we're not just yanking the rug out from under you tomorrow and it's totally going away. You'll be able to keep using simulation mechanical for a while. You'll even get some maintenance updates. If you're on perpetual, you could keep using it, and then it'll be more of a phase out than a hard stop, as you'll see. And then I'll do one more question here. And a lot of Inventor users here. And just wondering what sort of simulations that you're doing currently, that you're using simulation mechanical for. Okay, great. Yeah, a lot of static. Some people taking more advantage of the more advanced capabilities inside of there. So we'll discuss how we can various options so that you're covered for future simulation processes. Okay, I'll go ahead and close that up and get started here. So we'll just go into the details of the end of life for simulation mechanical, talking about what our positioning is, what our strategy and culture is, in a sense, going forward with the engineering tools that we provide. And then we'll also get into kind of a schedule of the phase out of simulation mechanical, at least from a support and updating standpoint. Okay, so just want to introduce you to the sort of the overall driving guiding principles, the ideology that we're using moving forward. So in past years, we've had more of a culture of designing a product, developing a product, and checking to make sure, is it going to pass or fail? Is it going to pass this test? How much will it pass this test? So more of a validation approach. Is this design good? Is it not good? Is there, if I make this little change, how's that looking? And so forth. So more of a sort of a down the road type of approach to validating our structures. And we want to more tightly integrate that whole design engineering process so that you're better able to make a more optimized product, do it correctly, do it optimized more upfront in a more innovative manner than pushing it further down the road and just getting something that's maybe good enough and perhaps making some errors along the way and paying the costs that are associated with those corrections to those errors. So we want to do that. We also want to make simulation a bit more part of the process itself, more integrated in the overall engineering process itself. And to various degrees, it's going to be visible, more visible or less visible. Probably what you'll be seeing more on the Nass Training CAD side and the Fusion side, it is tightly integrated, but it is a bit more visible on there. But we're also looking at sort of the invisible features. So sort of like optimizing the metal 3D printing process, for example, or doing generative design, coming up with the best option for a design just based on a number of inputs with minimal interaction, more of a, sort of an intelligent design approach to innovation and design and engineering. Also, we want to make it more of a standardized, integrated platform. So rather than using this platform for the design, using this platform for simulation, using this platform for CAM, rather than having all these different platforms, different environments, different interfaces that you're having to deal with and go back and forth between and learn different, interfaces for and so forth. We want to put it all together, make it, kind of all under one hood. More integrated, more intuitive to go from one step to the next than what we're currently seeing. And then we also want to make this thing, we want to make it accessible. We want to make that whole innovative engineering, that driving from design to an engineering process, a more optimized engineering process. We want to make that accessible and scalable. We want people, small companies, large companies, even individuals to be able to go in, do the engineering of their products, optimize their products, and so forth. So we're trying to make this accessible for just a broad demographic of, from the large companies all the way to the small consulting companies, or even, the small, the smaller startups, the more, some of the smaller innovative startups, for them to do the innovations that they're wanting to do. Okay, so with those ideas, our long-term vision is to enable the broadening of that technology. So if we take a look, behind the scenes, going into all this, there's a lot of developments in CAM, in simulation, in CAD, and so forth that can really change the way that things are developed and engineered. And we want to enable these technologies, put them before people so that they can take advantage of them in the most tightly integrated, efficient, innovative way possible. And that's what we're looking to do here, so that we're not just improving product performance, but we're optimizing new products and innovations. And what we want to do is, currently there's, it's typically been siloed in the past, as you probably know. So you typically have the design side, and then you have the simulation side, and then they're on their own silos, and then you might have a good bit of back and forth, which beyond just correcting a mistake that occurred further down the road, that lends some expense to the development process. But even the back and forth between going across the wall between design and simulation, that's also going to drive up costs. So what we want to do is sort of to better enable innovation, to better drive down these development costs. What we want to do is just help the mainstream engineers and designers take advantage of simulation to really come up with the best, the correct design, the most optimized design right off the bat, rather than making corrections down the road, having to go back and forth, between the experts who might actually be able to use their their resources more towards making even better innovations. So we want to be able to drive that accessibility. And then based on that, we really do want to move it all up front. We want that simulation to be design integrated. So, kind of sort of a back and forth. The design sort of driving the simulation. What are we going to look at here? But we want the simulation to drive the design. What should it look like that's going to be to best meet these performance requirements, these integrity requirements, and so forth that we're looking at. And so we just want to move it all up front as much as we can and stay away, move further from the post-design validation approach, which is more costly, less innovative, less optimal, and have it done more up front, right at the beginning. So if we just kind of put a matrix of our ideals, our guiding principles going forward here on the left versus what's been typically traditionally done in the past, we can see on the engineering side, we're really trying to drive it more from designing products to engineering products. And on the engineering, the conceptualizing the design earlier on, conceptualizing a more optimized design, rationalizing it for performance. So keep performance in mind, not so much, is it going to work or not? Yeah, we do want to do that, but we want to optimize the performance as well. Just have it be, like the best innovation or the best product that we can develop here. And then also look at the trends of innovation, look at the trends in manufacturing, look at the trends of engineering. We want to be able to capture those trends so that we're following, so that our customers, the users, can be on the leading edge of these innovations. And like I was getting into earlier, CAD integrated. So just a single integrated platforms. Keep it accessible. Break down the walls so that you're not jumping between different platforms. And then also make it intuitive, make it accessible. Don't sacrifice capabilities so much. We still realize that, hey, there's a real world out there, and the real world is complex. We want to be able to capture what's going on there, and we're using that to guide our approach as well. But at the same time, we don't want to say, kind of an older marketing approach was, hey, this is, just push a button and you'll get your answer. It's definitely not that. But at the same time, we want to do whatever we can to make it streamlined, make it accessible, build as much intuition and intelligence into the platforms as we possibly can. And you look at that ideal, that principle, and that positioning versus just the validation approach, where we're designing something and saying, hey, is this going to work? Hey, is this going to have this factor of safety that we need? So it's more just kind of validating something that's been developed and giving a yes or no, maybe going back and forth a good bit to try and drive it to something that passes, rather than something that's truly optimized and innovative. And at the same time, you're dealing with platforms that are less accessible. They're more compartmentalized. This person is an expert on this platform. This person's an expert on this platform. I truly believe, just speaking personally, that there's a lot to learn, but we've all learned a lot already. We can learn. People who know CAD can learn more simulation. People who know more simulation, they can learn design. They can take advantage, if they have a more consistent, streamlined, intelligent interface, they can take advantage of that to, build their knowledge and expertise in those areas and better drive that innovation. And here's a little bit of this is more of a graphic, I guess, of that previous slide. So this is more of a traditional process of designing. You come up with the concepts, you have some empirical data, you have your standard designs that you've been working with, through the history, and you do some analysis calculations, maybe some simulation or hand calculations, and then there's some experience built in. You know what's going to work and what's not going to work. Your prototype passes, and then you're good to go, and it's acceptable. but maybe you can, maybe you can save a bit of fuel on that aircraft. This looks like kind of like an airfoil, sort of. Maybe you can save a bit of fuel on the aircraft. Maybe you can use less material in this process. Maybe you can allow a level of performance that wasn't available before, that you hadn't considered, but would take you to the next innovation level versus your competitors. So we're taking more of that approach in mind, where we go through, and by moving the simulation to more of an upfront type of positioning, allow it to drive the design a bit more through its accessibility, through its consistency of interface, through its consistency of environment, and drive just a more optimized, innovative product at the end, rather than something that's merely acceptable and that's going to, maybe keep you afloat, but not necessarily move you to the next level to make these to make these disruptions, to make these innovations. So that's the driving thought. That's the driving the guiding principles, the positioning that we're taking with regard to simulation and its role within the overall engineering and innovation process. Okay, so we'll give you some scheduling, our direction and scheduling on the simulation mechanical retirement. So we have released SimMechanical 2018, so that's available. If you're a perpetual customer, simulation perpetual customer, you can, I kind of get a kick out of phrasing here that I hadn't really caught before, but you can use the software perpetually beyond the end of life. So yeah, by definition of perpetual, you can use the software perpetually beyond the end of life. Support-wise, you'll keep getting support through this year, next year, and even possibly 2019. So support-wise, you'll be all set for a while. So you can take advantage of that, more of a transition period than a hard stop period. We'll be phasing it out. So phasing out, not hard stop, over at least 2 years. So you at least have 2 years to work with that. And then we'll be moving to maintenance mode as we work to bring these next generation innovations and products to the forefront, to the user community. So we will still be getting some little patches, some little bug fixes within simulation mechanical via the maintenance mode over the next couple of years, while we are driving the other product development as well. So, and one thing I'll note, we're going to save the questions for the end, but go ahead and as you come up with questions, just go ahead and type them into the little chat window, the little questions window, and then we'll have those ready to go at the end, and our panel will answer those. Okay. So if we take a look at the time frame, besides the phasing out schedule, you've probably also learned that you get a free year of Fusion 360 Ultimate, and that includes the full breadth of the simulation capabilities in Fusion 360. So the basic and the more advanced capabilities that we have in Fusion 360 so far, and that's going to include that 360 Ultimate includes 1,000 cloud credits for your cloud solutions. So the phase discontinuation will be over a couple of years, and then Fusion 360 Ultimate, you have access a free subscription to that for a year, with the number of licenses or entitlements equal to the number of entitlements that you have for simulation mechanical. So we'll briefly talk about the simulation products moving forward. The two main options that you have here are the Fusion 360, more of the cloud-based and fully integrated into CAD design and CAM, a single platform for all these different tasks and sections of your project. So on the Fusion 360, that's a more affordable way. That Fusion 360 Ultimate is a $1,500 annual subscription, which is going to include those cloud credits versus the maintenance of simulation mechanical at $2,300. The Fusion 360, we'll see this is built upon the Nastran solver. So you fire off an analysis in Fusion 360 simulation, it's going to send it to the Nastran solver, the Autodesk Nastran solver, for the actual solving, and then the Fusion 360, that's going to act as more your pre and post processor. It covers the major workflows that you'd be looking at for an analysis, dynamic, static, and event simulation, and so forth. We are building more and more functionality into it with each of the versions. And the nice thing about Fusion 360 is you'll see an update like every few weeks or maybe a couple months. So since it is cloud-based, you get these updates throughout the year, kind of like an app. An app to update, they make some improvements, it installs automatically as you're firing it up. Pretty much the same sort of scenario with Fusion 360. And there are versus simulation mechanical, and we'll get into this further in the deep dive. You do have a couple of differentiators versus simulation mechanical. So we have the event simulation, and when I say event simulation, it even goes beyond the MES. We're talking actual post-failure type of behavior, so drop tests, beyond drop tests breaking apart, maybe like a fracturing of, sort of like a redundant design type thing where you might break a blade away and you want to see if the containment ring is going to catch it. That sort of approach. So more of a post-failure capability as far as the event simulation. And then we also have the shape optimization available inside of Fusion 360. So again, you apply this load, you have these constraints on it, and you want to see what's going to be the best shape, what material can I remove to get the best design for this. And then Autodesk Nastran in CAD, we've had that a good while, and it's still going to be there. We'll keep building on top of those capabilities as well as the interface. And that's going to be embedded. It works inside of Inventor as well as SolidWorks, so it's an additional environment that's available inside of Inventor or SolidWorks when you install it. Similar workflow to simulation mechanical. So again, just kind of your meshing, loading, solving, post-processing, similar workflow as you see in sim mechanical as far as the toolbar goes. You're going to see the similar thing in Nastran in CAD. It's not cloud-based, it is desktop-based. So you have the unlimited and unmetered local solves along with multi-user subscriptions available for that. So kind of a comparison between the two. The Fusion 360 is more cloud dominant as far as the solve, so you can take advantage of Autodesk servers that we use for these cloud solutions. So, like we have CFD cloud solves that have been available. It's the same structure, it's the same server bank, if you will, and it's constantly being upgraded and improved and so forth. And then those simulations or the solutions are more cloud-based. The sim mechanical is more local, and then the Fusion 360 is based on named user versus the multi-user with Nastran in CAD. Okay, and the name is right there in Nastran in CAD, and I did mention it for Fusion 360, but all of this, both of these applications, both these simulation applications, are going to sit on top of the Autodesk Nastran solver. So Nastran, many of you are familiar with Nastran. It's a recognized solver, recognized technology throughout all the engineering industries, aerospace, automotive, and so on and so forth. So it has a history there, a robust history there, and a deservedly well thought of reputation. So it's been verified with these NAFEMS benchmarks. Also, we got like 5,000 test problems per release to verify the accuracy of the Nastran solver. And you have a number of advanced capabilities embedded into it. So you can go beyond the static and modal, really dig into the nonlinear capabilities, the dynamic, structural dynamics capabilities, composites, and so forth. And since it is built as a solver, it's more of a solver technology, you can build whatever pre and post processor you want to on that. So you have that flexibility. We built Nastran in CAD on top of Nastran. we're building Fusion 360 simulation on top of Nastran. So since it is just a standalone solver, you do have that versatility as far as what environment you can integrate that into. Okay. So again, I'll go ahead and just encourage you to keep typing questions into the little question window on your GoToWebinar, and we'll address those at the end. We covered just sort of an overview of the options there, and now I'm going to dig a little bit into each of the products, at least show you the positioning and a bit of the workflow, and then we'll also see that we'll have a couple of follow-up webinars where we do more of a deeper dive into each of these products. So I'll start with talking about Nastran In-CAD, and that's just the simulation environment that you can add onto Inventor or SolidWorks, and then it brings in that CAD and allows you to perform your simulation runs, your simulation models on it. And so that's totally a comprehensive CAD integrated FEA. So if you go back to, you make some, you create a model inside of Nastran in CAD, you run it, you decide to make some design changes based on what you're seeing in the results. You can just jump back over to Inventor or SolidWorks, make the changes, update it, and run it again. So it's totally CAD integrated as far as that goes. And as with Nastran in CAD, with the retirement of simulation mechanical, we're as far as the capabilities go, we're focusing on that Nastran in CAD development. We're working on both making it more accessible and intuitive to Nastran in CAD users, and we're also working to integrate more capability into the Nastran in CAD interface. And like I mentioned, Nastran itself is a very capable solver. Lots of different areas that you can consider, lots of advanced capabilities that you can consider when doing your model. We're integrating more and more of that into the top level pre-processing interface that you see with Nastran in CAD. So a couple of examples of that. We have fluid structural interaction from Autodesk CFD. That's available in the latest version, 2018. And we've also incorporated the response spectrum, or shock response. We've incorporated that into the 2018 version of Nastran in CAD. And you'll look in there, you'll see other improvements that will be made, and you'll see some more significant improvements or significant updates and upgrades made in future releases. And as far as this, the schedule-wise, keep in mind we'll be doing this Nastran in CAD deep dive on May 23rd, just next month, and digging more into the capabilities that we have available, some of the tool sets, some of the that we have available that you can take advantage of. Okay, so just a quick rundown of the capabilities, and like I said, we'll dig a little bit deeper into this on May 23rd, but we can do both linear and nonlinear models with the static analysis. We have buckling capabilities, do buckling modeling. From a dynamic standpoint, we cover the full breadth of what you'd be looking for in a dynamics model. So we could do, just calculate the modal frequencies and mode shapes. We could do harmonic or sinusoidal excitation with the frequency response. And then we have the spectrum vibration capabilities available as well. So you could do random vibration or response spectrum, shock spectrum type of simulations. And then we have the event simulation. So again, more of a transient dynamic behavior, which would include nonlinear capabilities. So more of an arbitrarily time-varying load, such as an impact that you might have used MES for in simulation mechanical. You can do that inside of Nastran in CAD as well. You'll see one thing that might be a little deceiving. There's just it's a very, as far as the intuitiveness of the interface goes, you'll see it might look, it's actually, just like a single ribbon. You think, wow, how can they do so much in a single ribbon? But there is like a broad range of the load and constraint options that you might be looking for there, a broad range of meshing and contact options that once you do dig into the interface, you might find yourself, speaking as someone who started here just last June, once digging into the interface, you might find that, oh wow, there is a lot that I can do here with my model, a lot of complexity that I can take care of, a lot of ways that I can actually streamline as well, and we'll cover that in the deep dive. Okay. And the Nass Training CAD, it is used throughout different industries, energy industries, both green energy and traditional energy industries, industrial, manufacturing, automotive, and aerospace. We have Nass Training CAD is being used across the board throughout the various engineering and manufacturing industries. Okay. So, like I said, we will have a deep dive later on, but we'll just show you the workflow, kind of a basic workflow in Nass Training CAD quickly here. Okay, so we just open that up as a separate environment inside of Inventor. In this case, do a similar thing inside of SolidWorks. And then what we can do, we have sort of a linear static option selected now. But you can also dig into a number, you can see all the different analysis capabilities that we have inside of Nass Training CAD. And then as far as the idealizations, that's essentially your attributes. We have solids, shells. We have access to an extensive material library. So both the Autodesk material library and the Inventor material library are pretty extensive. You not only have just the basic metals, you get into plastics, you get into the different specific alloys and so forth, and they contain the Young's modulus and strength data and so forth. And then once we have those different materials defined, we can assign them to the different components of the assembly. And if you take a look, it's just a single ribbon, and you just generally follow it left to right, as you see at the top. So going from left to right, we'll constrain our model, our little trailer hitch. And this is just a linear static, so we're doing like we're towing a load, basically. So we've held it in place where it meets the car or the truck. Now we're going to load up that hitch ball, our trailer, and you have a number of options for, it's kind of important. It may seem trivial, but you have a number of options for the displaying of your boundary conditions and loads and so forth. Whether they're more dense, less dense, the size, and it's kind of important to have that visual verification that you're setting up your model correctly, and that's what we're showing here. So we've loaded it and constrained it. That's all stored in the tree, as you can see. So again, very similar to simulation mechanical, you can go into the tree and make these modifications as you see fit. And what we've done here is we've automatically generated some bonded contacts at the interfacing surfaces. And on a few of these, we want more of a sliding or a separation type behavior. So we can just select those contact pairs that were created and modify those. From a meshing standpoint, you have access to both global meshing controls, size controls, and local size controls, area, vertices, and so forth. And so you can really dig into the meshing options to get to really balance out your speed versus accuracy within your model. Okay, so we've applied our loads, run it, and you can see there's sort of some automatically generated plots, the von Mises stress, displacement, safety factor, and so on. We can go in there, we could dig into the options either through the pull downs or the results options and change what we want to look at too. So you see the four predefined quantities, but you have the full range of other quantities available as well, including stresses, strains, deflections, and so forth. And for contacts, we can look at contact behavior like contact pressures, contact statuses. So another option that we have available. We can also take a look at reaction loads, make sure that they balance with our applied loads. And that's it. That's the general process. And like I mentioned, just want to show that to you really quickly so you get an idea of what that workflow looks like. And then we'll be digging into it further on May 23rd. So you see more there. And as far as the Nass Training CAD resources, you have that installed. We can also provide a link. If you're interested in, I mean, through watching through GoToWebinar, you're not going to want to type in what the link is. But if you're interested in just kind of reading through the Nass Training CAD help manual and know more about what's going on there, we can provide you that link. And when you get into it, you'll also see if you're just learning it, if you have it installed and you're learning it, you have access to a number of tutorials, both on the basic level and the advanced level. And then there's also self-paced training that's contained within the help system as well. And so you can go through there and follow essentially the same training that you would go through if you took a standard training class, with the only thing missing there being the instructor to ask questions to. So that's some items that you can take advantage of as you're picking up on Nass Training CAD. Okay. And moving on to the next platform, Fusion 360. I will be focusing more on the simulation capabilities here, but keep in mind that Fusion 360 is a fully integrated engineering platform. And so we're just looking, we talk about the future of making things, the innovations, the disruptions, the, designing it not only right, but designing it optimized the first time right off the bat and being able to make these disruptions going forward. So, for example, like customization, mass customization, low cost customization, optimize designs, more product sophistication. So the Internet of Things, we talk about the Internet of Things, and even non-electronic, even more mechanical components are making these advances, having these technological advances made to them. And then with the area, within the realm of manufacturing, you hear a lot of hype regarding 3D printing, and there's a lot of good stuff going on there. We're moving, for example, metal and additive manufacturing, that's going from the lab to actual production. So it's another tool in our manufacturing tool set. But not to be, sort of the jealous older brothers, your other types of CAM, such as, automated milling and lathing and so forth, you have these advances being made to subtractive manufacturing technologies as well, and other processes for developing or for manufacturing that are being developed, that we want to integrate those processes within that same engineering platform. So everything being considered here, we want to make it accessible, a common environment, a common platform, intuitive across the board, and accessible across the board. That's what we're looking for here. And just some of the questions, some of the things that people are demanding. They're looking at, light weighting their structures, minimizing the material used in the structures, more advanced materials being used in their components. They want to take advantage of more advanced manufacturing processes, especially as they come online and especially as they start to become, as the cost of those processes starts to drop. And then also the electronic integration, the smart components, the Internet of Things, want to integrate that as well into traditionally mechanical types of applications and products. And so with all of that in mind, we decided with Fusion 360, we want this all in a single platform. We want the design, the development, the simulation, sort of the simulation design, the simulation-driven optimization. We want that all in a single platform. We also want to drive it more towards the manufacturing side. So again, figuring out your manufacturing processes, put that in the same platform, the same environments as where you're doing the rest of the engineering and development work. And so that's that idea behind that Fusion 360 platform. Okay, so as far as the manufacturing, the manufacturers, what they're concerned about, what they're looking at to not only stay afloat, but to move ahead, to innovate, to disrupt in the marketplace, they have a number of questions that they're constantly asking so that they can stay on top of it. So, you know, they're looking at how do I study the interactions? How can I make this lighter? You know, what's the risk with this innovation, associated with this innovation, and so forth. So they have lots of questions, you know, even more so now than in years past. And so that's the idea behind the Fusion 360 package. And we can see, if we take a look at the packaging, there's the standard Fusion 360 and the Fusion 360 Ultimate. You have different tiers of capability across the spectrum between CAD, simulation, and CAM, between the standard and the Ultimate packages. From a simulation standpoint, you can see that the basic package includes your static stress and modal frequency, and then thermal and thermal stress. If we move on to the advanced level, that's going to include buckling, nonlinear stress analysis, event simulation, and shape optimization. And again, I'll note that on June 14th, we're going to have a deep dive webinar digging further into the Fusion 360 capabilities and interface. So get some good examples, good discussion there. So the simulation today, if you look at the basic level, so this is included in both the basic and Fusion 360 Ultimate. So we can do static stress analysis. We can do our modal frequency, so we can figure out, you know, what's our frequencies and our mode shapes. Thermal, so we can figure out our temperature distributions based on thermal loads. And then what we can do is we can map those thermal loads, or those temperature results, I should say. We can map that back to a structural analysis to calculate our thermal expansions, our stresses due to thermal expansions, and the you know, the difference in material properties between interfacing components. Figure out if we're going to have any problems with that thermal expansion or not. And then stepping it up a notch into the Ultimate package, we have accessibility to shape optimization. So the lightweighting is kind of a focus here. Material savings, so what material can I remove and still be able to satisfy the requirements of my structure, of my loads. And then we can also account for buckling, so thin-walled structural buckling, you know, column buckling, beam buckling, you know, things like, you know, just any sort of thin-walled body, or perhaps, you know, maybe like a piston rod in a vehicle. You don't want it to buckle. You want it to run your crankshaft, right? And then for more realism, we can get into nonlinear statics. So essentially looking at post-yielding behavior of our structures. So maybe you're looking at what happens after I do bend this thing out of shape. What level can I go to before I actually break it? You know, sometimes that's a valid consideration to be made, and it's actually a pretty common consideration to be made in various applications. So you can take a look at that as well. And then bumping up the realism even further, even to a new level of complexity that we have, is this event simulation inside of Fusion 360. So it's not just an impact, it allows impact plus failure. So we can see this example of a ball crashing through a wall, for example, and there's, you know, so many implications for that, as far as, you know, what happens if, you know, if I drop this, will these break? If this breaks away from this, then is it going to break too when it hits? You know, sometimes you drop something and you're okay with things coming apart, but you don't want them to break apart. So you can allow that sort of complexity in your modeling with the event simulation. And as far as what you have available, some additional tools and capabilities that you can take advantage of to even further improve your ability to make these decisions, make these optimizations. So we have a pretty extensive set of onboarding and learning within the Fusion 360 help. So if you fire up that help, you'll see there's so many sections that you can get to, or all these different sections that you can get to with the 360 interface all on its own, both the design side, the simulation side, and the CAM side. And then, digging into any one of these, you can get into these overview videos, these training tutorials, and so forth, access online videos with some additional tips and tricks and so on. So there's a lot that's integrated within that Fusion 360 help system. And just to reiterate, this is running on top of Autodesk Nastran. And of course, the version is going to be updated with the version of Nastran. So it's not just 2017, it's updated to 2018. And for more complex assemblies, you can sort of simplify that setup to speed up your analysis, both on the meshing side and the solving side. And then you have this comparison capability. So if you do different cases, different load cases, you can compare the results of those different load cases, put them up next to each other and see how one compares to the other. So you might be looking at, well, if I constrain this component this way, okay, how is it going to behave versus if I constrain it this way? You can do that kind of study. You can also do cloud solves, so that can free up your resources. You can, instead of having your computer bogged down and keeping you from working on your Excel or whatever else it is you're trying to do, you can send it up to the cloud and have that do all the crunching. Save yourself from having to invest in a server cluster by sending it to the cloud instead. You can do quicker explorations with that. So for example, if you do have multiple load cases, you can send the whole chunk of load cases up to the cloud to be solved all at once, rather than having to solve them sequentially locally on your computer. So you do have just a ton of options there. And not only that, you have that mobile access, that cloud access. So if you want to access it from, maybe start something off at work and take a look at it there, and then log in when you get home and take a look at your results, make sure it's run the way you expect it, you can do that. If you're out on the floor somewhere, out in a meeting, you can whip out your iPad and say, here's what I'm looking at as far as my results go. So that mobile accessibility is advantageous too. And then just digging into more of what you'd be looking in these real world assemblies, we do have these bolted connections. So if it's important that you don't want it welded, you don't want it to separate, but you want to tie it together using these bolted connections, you can simulate that to essentially better, more accurately capture the effect of these bolted flanges. So especially if assembly loads are important to you, or just that overall pre-stressing of your structure is important to you, you can create those inside of Fusion 360. Okay, so just sort of comparing the cloud versus local. You can see the cloud, you can do multiple solves. I see I'm kind of running low on time, so I'm going to speed through this. But basically you're unlimited as far as the hardware goes. And then again, you're not hogging your processors on your machine. You're taking advantage of the servers off in the cloud. And the availability is really, you're not going to run into any walls or any limits as far as the availability of these cloud solves, except from as far as cloud credits go. But as far as the resources themselves, you're not going to run into a problem with that. And again, unconstrained, you can look it up. You can look up these solutions elsewhere. Okay. So again, we'll just do a quick overview of that Fusion 360 interface. And you can see we're starting from the modeling environment, more of a design environment. And again, it's just another environment that you open up. You see all the different capabilities there. And what's nice is if you're not as familiar with what you'd want a capability for, you get to see a description of what you're solving with that particular form of modeling. And you can even read up on it further if you want help choosing a study type. So you can see we had the three bodies that came over from our design, from our assembly. And material-wise, the typical process is we will specify what materials we're making this out of at the design level, at the assembly level. But if we do want to change them at the simulation or analysis level, we can do that. So maybe we do want to explore, hey, what happens if I use aluminum for this component versus steel? Can I feed that back to design? You do have that capability. And you also have a number of libraries that are pre-assigned, both nonlinear and linear material properties. And you can also store material properties to your favorites library to sort of speed up that access, because the existing libraries are pretty extensive. And you see, as far as the constraints, we have a number of constraints available, including rigid body connectors tying bodies together, as well as the bolts. And again, all the different constraints, a wide breadth of the pin constraint, frictionless constraint, and you can pick whatever directions you want to leave free up and leave constrained. So in this case, I'm just constraining that upper and lower surface of the larger lug. And then again, we're moving essentially from left to right across the toolbar, kind of our standard. And again, a number of loads. There's the applied loads, but you also have acceleration loads, including gravity loads. And a nice little feature is that you have this point mass. So maybe you have like this really complex motor that's hanging off your structure, and you're only interested in the effect of that mass vibrating on your structure, that mass of that motor on your structure. You can essentially automatically replace that motor, that complex assembly, with an equivalent mass to distribute the load better. And you can see, as far as the applied loads, we have a number of options there, including force, pressure, remote force, and so forth. And then a number of options of applying the force. So we could do it normal. We could do just a vector XYZ direction loads. And what's kind of neat, you see that limit target. If we pick that limit target, we can say, I want to confine the load I'm applying to this little region here. I don't want to apply it to the whole face. So instead of like splitting the faces, you could do it that way instead. And then we'll automatically seek out our contacting interfaces on this and generate contacts at those interfaces. It'll default to bonded contacts to essentially weld that assembly together, but we'll see that we have some options as far as how we define those contacts. And we see that we have, not just bonded, but we can specify separation, sliding contact, and so forth. And we can either look at that as on a contact pair basis, or we could just look at it based on what's being tied together and expand those and manage our contact pairs that way. So a number of options as far as how we visualize and manage those contacts. And then if we want to generate contacts manually, you can either do it through that manual, through that manager, or through the toolbar. Meshing wise, we have access to both global and local settings. So just a global size, we would just manage under the general settings, the mesh size. That rigid body modes, what that'll do is if you have a direction that's unconstrained, it'll create weak springs for you to stabilize it in that direction so you don't have that rigid body issue. We could adjust the global refinement with some additional advanced capabilities on specifying our mesh size and behavior and mesh shapes. And we can even do an adaptive mesh study on this. So we want to make sure that we're converging on a consistent result between runs, between meshing refinement runs. We can set that up to go to run automatically. And then from a local standpoint, on those fillets, I wanted a finer mesh, so I set up my local settings, and I can specify a size or just move that slider, and I get this nice little mesh seed preview that I can take a look at before I move forward with that meshing operation. And then from there, we can go ahead and mesh, generate that mesh. And one thing you'll note, even if you don't go through that automatic contact step, when you do the mesh, you have that option to have it automatically generate the contacts at that point. And then we solve this. You can pre-check the model, so it double checks and makes sure that everything's set up for the solution to be executed. So you can just run a little pre-check before you commit to the solve. And notice for the basic analyses, you can solve on the cloud or locally. The more advanced is on the cloud, but the basic solves are going to be available on the cloud or locally, and you can see how many crowd credits it's going to take to do the solution on the cloud. With the static analysis locally, I could only do one solution at a time. If I had multiple load cases, I could run all those load cases simultaneously on the cloud. And so I won't make you sit through a solution. We'll just move on to the results. And that's kind of typical von Mises stress results display. You can see you have pretty much the full range of stresses and strains that you can look at. The different directional strains or stresses, principal stresses, and so forth. And you can also do, I'm going to just jump ahead because we are short on time here. But I'll note, we'll dig into it in the deep dive, but we'll get into the comparison. You have some additional capabilities as far as viewing the results. You could do like a slice plane and check your results that way. So some nice little results display features that we can get into. And as far as learning, like the best place to start is just that Fusion 360 menu. Let me jump back a slide here. Just that little question mark in the upper right-hand corner. Just click on that, and it'll take you to this help system, and you got access to these how-tos, hands-on exercises, little overview videos, little tips and tricks videos. So definitely take advantage of that. It's very extensive what we've built into there. Okay, and just coming up, just a reminder, we do have on May 23rd, we're doing a Nastran In-CAD deep dive on that and showing the path forward on that one, and then doing more of a deep dive on Fusion 360 on June 14th. So since you do have access to Fusion 360, I do encourage you all to start using it. And notice that, we talk about cloud credits, but notice that we do have access to local solves. So, as far as sort of getting up to speed, getting to learn it, go ahead and take advantage of the local solve. So if you're just wanting to see how something happens, you're not using your cloud credits on that. So, just kind of get in there and play with it and see the behavior. That Fusion 360, let us know if you have any problems accessing that. That is going to appear in a separate contact, and it's the contract manager for your company is going to have to assign it to specific user or users. So whoever's running that, you might need to talk to them as far as getting that set up and accessed for you. And then just simply download it, install. It looks like it's a trial login, but it gives you the permissions that you need to run Fusion 360. And then as far as getting in CAD, just simply contact your local partner, your local reseller, or direct Autodesk sales rep if you're interested in that. And another thing that I just recently learned about is that we are going to have a number of ongoing webinars that are more industry and product targeted for both Nastran In-CAD and Fusion 360. Those are in development. We don't have a hard schedule yet, but go ahead and keep an eye out for those as well, because I think those are going to be of interest to a whole lot of you on these more in-depth industrial or product-specific studies. So I've pretty much run it up against the wire, but I wanted to open it up to the questions that we have here. Okay. So let's see, as far as the panelists go, do we have our panelists there?
Yes, sir.
Okay, great. I want to make sure I still had audio. I was getting a little concerned for a second. How are the questions looking?
Good. I think a lot of them, by the way, my name is Dave Graves. I actually work on the Fusion team. I think a lot of them, when we dig into the workflows and in the webinars that Jeff has mentioned are coming up, I think you're going to get a lot more answers into that. So I encourage you guys just to spend a little more time with us, and we can dig into the workflows of both product and just dive a little deeper to some of the things you guys are bringing up, whether it's cloud credits or capabilities, etc.
Okay. And it looks like, yeah, it looks like we've been answering those as they've been moving through. And like I said, I think a number of these questions will get answered in future webinars as well. Do we have any outstanding questions that we want to address here? I see we're running a little bit over that hour. Okay.
No, I think we're good, Jeff. I think a lot of these questions really roadmap related, capability-wise.
Okay.
I think that, you know, to Dave's point, I think that we'll be covering a lot of these in the upcoming webinars.
Okay. All right. Sounds good. I appreciate that, and I appreciate you all attending this webinar, and hope to see you in more of the deep dives where we dig into this a bit more. And let's see. Oh yeah, as far as, you know, some of the functionality, Fusion 360, I kind of wanted to emphasize that, even though you do have that, you know, the CAD integration, it is able to read in any CAD file. So any, you know, direct CAD file like SolidWorks and NX and so forth, it can read those in, and it can also read in the neutral files such as your step and Parasolid. So all of those can be brought into Fusion 360 regardless of what CAD system you're using. So I do think that's important to note, and I want to make sure you all know that. And then, yeah, roadmaps and that stuff, that's, yeah, we'll certainly communicate once we, you know, have, you know, updates in place and know where, you know, for each version, we'll certainly keep that communicating as well. Okay. So I'll go ahead and close this for now. Like I said, we're running about 5 minutes over. So again, I appreciate you all standing up and seeing our plan going forward, and what we have available going forward as well. Everyone have a good day.